As I was saying before getting so rudely interrupted, be aware that sometimes the Angry Bird can come in from the back and distribute itself through to the back. So now we can keep going. Use distributive property to factor out the greatest common factor and identify an equivalent expression. So it actually tells us what property or what skill, what strategy we're going to use to simplify this or to create an equivalent expression. And that is the distributive property, but we are going to factor out that greatest common factor, which is the angry bird, correct? So let's figure out what that angry bird is. I know I can pull out a 9. That'll give me 6t, bring down the minus, which will give me 9 times 2s is 18s. I notice both of those are still even, so I can still pull out a 2, which will give me 3t, bring down the minus, 2 times s is 2s. And from there, I am good. So what is my angry bird? It's not 9, it's not 2. It's actually both of those together. It's 18. And then my pigs are the 3t minus the s. That one's a little bit different, so let's double check and make sure we did that correctly. 18 times 3 is 3, 4, 5, 54, so that's good. 54, and then don't forget the t, minus 18 times s is 18s. Are those the exact same? Yep. So that tells me that this is my equivalent expression. 18, and that's the angry bird, the greatest common factor that it was asking. We factored it out, didn't we? We pulled out that 18. All right, this is not in your notes, but I want you to see if you can be the teacher. What mistake was done? If we look at this, this is a common mistake that I see a lot. I see students doing 4 plus 2 and they get 6. And then they decide to distribute the angry bird through. Here's the problem with that. You guys that do this, you are adding and then timesing. And according to order of operations, that is a big no-no, isn't it? We always multiply before we add. So what we really need to do here, let me rewrite it, is do the distributive property first, distribute the angry bird through, because we're going to times for both of those. 2 times y and 2 times 3 is 6. Then we can combine the like terms. You might be like, well, now look, there's not like terms with the 2. No, but there is like terms with the 4 and the 6. And like terms with the y and the 2y, isn't there? So let's combine those. Y plus 2y, well, if that's 1y and that's 2y's, then now I have 3y's. And then a positive 4 and a positive 6 will give me a positive 10. So where was my mistake? They added and then times when it should be times and then add. Okay? All right, I think you're ready to see if you can do this on your own. You be the teacher now and you figure out what the mistake was. So maybe write this down. It's already in your notes, right? So rewrite it off to the side and you solve it yourself and then compare to what they did. What mistake? Well, looks like they did multiplication first, so they didn't make the same mistake that we talked about earlier because they got 5x plus 20, so they're good there. Then it looks like they're combining like terms. So they got their x's and their constants. 2x and 5x would be 7x. And then, I see what they did. They have a negative 2 and a positive 20, and they combine that to be 22. It's not, is it? This is a negative 2 and a positive 20. So that would actually be just a positive 18, wouldn't it? Be 20 minus 2, which is 18. So it should be 7x plus 18. They did not combine the terms correctly. They added a negative term when they needed to subtract a negative term. Will you generate an equivalent expression here? What do you get? Well, what I get is I see that backward angry bird, and I'm going to go 2 times 6x, which is 8, sorry. And then 2 times 3 is 6. And then I have that 8h. So I'm going to combine those h's. and get 20H plus 6. And there you go, my friends. That is how you can generate equivalent expressions.